Welcome to solverfy.
Hello there. So for this exercise we need to count how many partial functions, so this is important, partial functions are from a set with m elements to a set with n elements. So technically we're defining here a function f that goes from a set A to a set B. The number of elements in A is m and the number of elements in B is n. If this is a total function or just a function, the number of possible functions is going to be n to the m power, right? Because we can assign n elements to each element in A, right? So that returns to, that means n to the m power. But the fact here is that we are dealing with partial functions. So what's the deal with partial functions? So the point is that a partial function from A to B can be can take, so here you have your set A, it's going to be your definition domain, and here you have your set V. So you can map one element here in A to one element in B, or to an element that is called undefined, okay, because it's not part of a subset of A, that is going to be part of the subset of the partial function, okay? So when you have a partial function, you're technically taking a subset from A and you're mapping to B. If you pick an element outside of that subset of A, then you're mapping those elements to an undefined term in B. So this point here that is outside of that subset, it's going to be mapped here to an undefined value on B. So the change here is that V, your range, can be either an element of B or can be an undefined element. So that means that your domain, your full domain, it's going to be your full range, sorry, of your function. So the range of your function, it's going to be n plus one element. This plus one is due to that undefined value that your function can take, and the rest is just following the same statement as that I said before, that is going to be n plus 1 to the m power.